Okay, everybody, welcome. This is the section number 2 of the Java Programming for Android class. This is the advanced section. We're picking up with inheritance, and we're going to go from inheritance forward. We're going to review some basics. So the first hour is going to be just a review, just to get everybody on the same page. Some people program in different programming languages, including myself, so this is actually good for me. Start thinking in Java again from Objective-C or from other languages. So what we're going to do is going to run through some basic concepts. If you open up Eclipse, you can do this with me. I'm just going to type on the fly, so it'll be at the same pace that you're typing, or slower because I'm a slow typist, but hopefully I won't make too many errors. So from last time that we were here, we installed the Java Eclipse, so we're looking at an Eclipse window. I have some examples preloaded, but I'm going to start fresh. You don't have to download anything right now. You don't have to start with anything. I'm just going to basically give you a whirlwind tour through everything we covered last weekend, just in case you weren't even here last weekend. You'll be up to speed. And then after that lecture, we'll take a small break, and then we'll start in with inheritance and interfaces and stuff like that. Well, actually, a little bit past inheritance. We're going to take us through inheritance. Alright, so if you have Eclipse opened up, go ahead and go File, New. And just select Java Project. We're going to create a Java project. I'm going to go through the fundamentals here. So I have a Java project here. I'm going to give my name of my project. I'm going to call it Review. Review Java, or I'm going to call it Java Review. And I didn't leave any spaces in here, obviously. I made it capital, the second word, I capitalized the first character so that I would have no spaces, so it's easier for me to read. And then use project here, and it says, what does it say? Create separate files, folders. Just leave everything on the defaults. This is what we were doing last time. Go ahead and press Finish. All we did was created a new project. If we open up the new project, I see an empty source code directory. So everything in Java is formed in the pattern of a class. We could create classes for everything, so we have to make a class just even for Hello World. So I'm going to make a class, and I'm going to go up to File, New, and then I'm going to go down to Class. And did you have a question, or? Let's see. Oh yeah, we already have them printed out. Yeah, can you bring me like about 5 of them? Oh, just bring me about 5 of them.
Okay, I'll keep it.
I didn't know it was there. Where is it there? There. Where is there?
Next to the water.
Oh, I'll get them myself. I'll get them myself later. Okay. Okay, so we're going to make our first class as part of this project. Go up to File, New, Class. So in here we're going to actually, this is the meat of all of the components that we're adding to our projects in Eclipse, by the way. And for the day we'll probably be working with just folders, classes, files, stuff like that. So class. And then in here we're going to create the main class that's going to be our driver program. Not a bad way of starting out the project if we're building something from scratch, and we want to, because eventually we're going to need a driver. The driver, if you remember, was the main. So I want to make sure down here on the bottom I want to select this public static void main. So I have a main that is going to be part of this class. And I'm actually going to call this class main, actually. That keeps my memory in terms of which class this is in the project. It's the main driver program. These are concepts I went over last time that I'm kind of refreshing, or whirlwind tour here. So this is what we did. And do we want constructors from the superclass? Don't really need constructors. It's just going to be a driver program. Don't really need it. I'm not going to inherit any abstract classes or methods or anything, so I'm just going to press on Finish. And if I press on Finish, I've got public class main, and in here I have a main that's going to take on a string argument command. If I run it now, nothing happens. If I wanted to create hello, I could put a line in here. We learned from last time we have system.out.println will print something out. So if I start just typing in system, if I spell it right, oops, I can see all of a sudden all of this automatic thing. If I press out.println, if I choose to click on the little help that comes up, then I can put an argument here, and this is going to be hello world. And we have to put a semicolon at the end of every line. And so now if we run the program, we just click on the project, right mouse click, go down to Run As, Java Application. You can also do from the Run menu up here. We now have this lovely little console application that says Hello World on the bottom. So we have system in, system out, to get input output from the keyboard. It's kind of like C and C out, printf, scanf. Our standard I/O library. Went over that last time as well. So we have that. So then we built Hello World, and then we said, well, this is stupid. We need like a class or something to work with this. So the concept being we build a bunch of classes, we make instances of those classes in the main, and then we run and we do the behavior. So I'm going to start out with a simple example. It's actually one that we did last time, but I don't think we did pencils. We made different types of pencils, if I remember this. I'm going to change the theme a little bit. Make it humans, and then from the human, or a person. We'll start with person. We'll make persons, and then we'll make students and staff and employees and stuff like that. We'll make a little hierarchy of that. So when you think about the hierarchy, and we talked about hierarchies last time in terms of inheritance, we want base functionality. And then the base functionality is going to keep some information in there and have some methods. And then we're going to have functionality that's derived from the base functionality. For example, every student is a person. Every teacher is a person. So we'll make teacher students, and then we'll make graduate students that are different types of students that are also people. And we'll build a hierarchy. Here we did this with dinosaurs, if you remember. So instead of making dinosaurs, let's make people this time, actually. I thought it was pencils, but I remember dinosaurs, actually. And dinosaurs was one of your assignments. So after we get done with this review, we'll pick up the first assignment, which is going to be number 3. And we'll see what that's about. And then we'll work towards that one and probably build that one in class as well. So if you keep everything we're doing, you'll have some good examples, hopefully, that you can reuse further down the road. If this is brand new to you, if this is not brand new to you, hold on, we're going to go extremely, we're going to advance pretty quickly here. So let's put another class in here. And if we're going to build a program that keeps track, this is an HR program, how's that? If we're going to build a program that keeps track of people, and let's put a person in here. So I'm going to click on the source code directory here for the default package. I didn't create a package. If I wanted to create a package, I could, and it would show up under here, and I'd have different packages. If they were all public packages, then I could share files between them. But I want to put it all in one package if I'm going to use them in between different instances of different things I'm going to create. That way they can all easily see each other. There's different ways of organizing this. I'll get into that a little bit later. But for right now, let's just put everything in one package, and we'll be good with that. So go ahead and go File, New, Class. And call this one person. Remember, we always start out with a capital letter, and the same name of the file is the name that is of the class that's declared inside of the file. Remembering that. We're going to make it public, so I have a modifier here. And we went over access modifiers last time as well. We have public, private, protected. There's public means it's going to be available to everybody. It has to be if we're going to make it a base class, actually. We could make it abstract. And I don't think we had talked about abstract classes yet, but abstract classes we can't make instances of. So for this example, if I made this an abstract class, I wouldn't be able to make a person in a few minutes. So we'll look at abstract classes today, however. I'm not quite sure we hit that yet. Abstract classes, you know, if it's going to be a base class, and the base class is going to be something like a shape as an example, and you're going to have a method in there maybe, for example, area. But you don't know exactly, at this point, you don't know exactly what kind of area the shape is going to have. How you're going to calculate is going to be time, height times width. Is it going to be a circle? We have to deal with radius. What kind of area we're going to calculate? Why put it in there? If you put the code in, then what ends up happening is you end up with the concept of there being like this wrong shape area that's being calculated. So if you make it abstract, leave the implementation for later. You make it abstract, which means you can't make an instance of that object, but you can make instances of objects that are inheriting that abstract class. So here's person. Person's going to be public. We don't need the public main. So after we have our main, and I saw this with a couple of programs that people sent and said, hey, is this okay? I looked at it and went, every single one of your classes has a main in it. I'm thinking, how does that even compile? Or it's one program that has a bunch of classes in there along with a main. And I'm like, how in the world does that even compile? It will compile, actually, but it's odd. I guess you have to really tweak it to get it to work. What you're supposed to do is put every one of your classes in a separate file, and you only have one main. One main per project, and that goes in a main object. So don't put the main in the bottom of some derived. This is the most popular thing, is to just the last derived class, you put a main in there. I'm like, whoa, okay. So anyway, if you want to do good practices, split it all out. There's no problem with having multiple files here, because you can always put them all back together when you deploy this application. Put them in a jar file, and then all of the files are all put back together, and it makes logical sense. All right, so no main in here. Do we want constructors from the superclass? Well, there is no constructor, but we could put one in, but we're going to build them manually. I don't want to do any of the automation right now, so let's just go ahead and go finish here, as we're building a base class. Now I have a person. Inside of person, I can have variables, so I could put the variables in. And the variables I'm going to put in here are, let's see, string name, let's see. And string is an object, so I'm capitalizing it. Integer. Oh, let's call this one age. I know it's a bad design. What else does a person have? That's about it. Let's just go age and name. We can always add stuff to it in the future if we want. So, actually, let me pause this for a second. I see our chairs have arrived. Okay, we're back.
So,
yes?
So if we declare a class as a default, so if
what do you mean by default?
A default class?
Yes.
Instead of a public?
You're going to put the word default there?
Yeah. So
I don't think that's going to work.
So if it is a default, then it will be accessible through all the packages?
Are you talking about this option here? New class
And default, yeah.
Default. The name is empty. Well, I don't actually, let me see what it does here actually. Let me see. Another person. By default, I think it's going to be public, really, but let's see. Class. Oh, there's nothing. Huh, nothing.
Yeah, but
it left out the access identifier.
Through all the package, or within the package it will be accessible to
well,
all the classes?
let me just specify first of all that this is non-standard Java. It's an Eclipse option that was selected. Normally you want to put something here like public, private, protected. Because there's nothing here, by default it'll be public. It's really bad practice though to leave it this way, because what ends up happening is further down the road you have to remember, well, what was that? If you just write the word public, then we know it's public. But default's going to give us the default type, which is public. So it's just like the default type for variables. In fact, I'm going to delete this class because we don't need it. But if you leave the class, if you leave the access method out, access modifier, excuse me, out, it will be public by default, which is the same as putting public on there. Why they have that option, I don't know. Maybe people don't like the typed word public. I don't know. So I'm going to remove this guy because he doesn't really belong. I'm just going to, it was just for illustrative purposes. If I don't put anything here, which I haven't put anything here by default, these guys are private. So the data is private, the class is public. Private meaning it can only be manipulated inside of the class implementation. So in order to use this guy, actually right now I don't need anything. But normally you want to automate the construction of this object. Also you want to initialize the data. So usually you have a constructor that goes into place. This class right now will work on its own, however, if we want to. In fact, if we come up here and I close this, unless Eclipse complains about the lack of constructor, what I usually did, what I have done right now is left out a constructor. I'm going to leave hello world in here because we want to see that the program actually works. But in here I'm going to make an instance of this object person. So I'm going to say person P. I'm not doing anything with person, which is going to be this warning message here. It says the value of the total variable P is not used. Yes, I know. I can do this. I can go person P. So let's make an instance of an object. Review that concept. I can say person P. I can say, and that makes, I'm going to leave this because I'll just leave this as one of my examples for later. I'll just upload it as soon as when I upload this video so people can see the final product. But person P, this is called a reference to a person object. There is no object created, however. It's a reference variable. Same thing in other languages. If I say P is equal to new person, then I've allocated the object. Is it this way? There we go. This allocates the object. I have to get back into. I'm now refreshing mine because I just did Objective-C not too long ago here. So getting back into my Java syntax. So we can also do it together as we hopefully remember. I can say person, another person A is equal to new person. Now I have actually done both, so I have allocated and referenced. So allocated, it makes, oh, actually the cheat sheet is the word new. If we're creating a new person, we're allocating the space for the object and we're creating it. This isn't going to do anything. If I print it out to the screen, I've got nothing is going to happen. Hopefully it will work though. And I have hello world being printed out. So when I make these instances of objects, I can also run what's called a constructor. I had some questions about constructors, so I kind of want to review this as well. So we're going to be reviewing everything. So I'm going back to person. Let's write a constructor. Constructors have the same name as the class name. We remember this, right? They're also public because we need to access them outside of the class. Anything that's private is only accessible inside of class. One of the things that's private in this particular case is that string name and that string integer age. So I'm going to write my first constructor. My first constructor is going to be the default constructor. So I'm going to go public person. And I've created, at this point, a default constructor. So I'll put up here default constructor. I'm kind of documenting this only because it's not a bad idea to, because then people know what you are talking about. So if I have a default constructor, what am I going to do? Well, I'll probably set some information for the variables that I've got. So I'm going to go name dot, and last time we looked at the concept of this dot name is equal to unknown. So now I've set this object's name. This object's name is equal to unknown. And then let's see, this dot age, this is review as well from last time, is equal to, now I'm going to give this one here, I'm going to make this person 21. So we have age is equal to 21. And I've initialized the data. So let's create another constructor that's going to initialize the data for us, because what if we want to make one that's not just 21 and not unknown? So I'm going to go public. I'm going to do the same thing as before, but I'm going to put parameters in here. I'm going to make one that takes on both. So essentially, if I have two variables, I'm going to have probably 4 or 5, depending upon how I do it. I'm going to one for each one, 1, 2, one for both, 3, one for the default, 4. I could possibly come up with 5 constructors. I know there's a tool in here to do it automatically, but it's like trying to, if you teach math using a calculator, which is what you're doing if you use those tools, the student sometimes doesn't understand what's going on. So we're going to do this all manually. But yes, I know students always say, but there's an option. You can just create those constructors for you. I know, but let's not do it that way right now. It's like using a calculator to do multiplication and division. Okay, so I'm going to make another constructor here. Public person. And in here, I'm going to say integer age, comma, I'm going to call it A, comma, string n. And in here, I'm going to have some opening and closing brackets. And let me get rid of this window down here so you can see this. I have another one. So I've given it 2 parameters using the data types, and the data types are A and N. Excuse me, the data types are integer and string. The variables I'm going to take in is A and N. I'm going to copy A and N to this dot name and this dot age. So I'm going to go here and go, this dot name is going to be equal to N. And then this dot age is going to be equal to A. So now I've created another constructor, and so I have 2 in here total, and so now I can run whichever one I want. So as an example, if I wanted to run this one, let me go back here to main. So I don't actually, okay, so when I run the default constructor, I don't have to do anything. These guys are all running the default constructor. If this one here that allocated and reference all in one, I can just pass it two strings. And then it's not going to be running the default constructor anymore. It's going to be running my new constructor. So person P, the first person, is going to have unknown and 21. And then person A, the second person I'm creating, I'm going to pass the arguments from main to the method, the constructor. Excuse me, the constructor is not really a method. It's a special kind of method that's going to allocate my name and my age to this age and this name. So I'm going to put in here, because the age came first, I believe, so I'm going to put in here 50, make this person 50, and put in the name here. This is Bob, and Bob's 50 years old. So we made Bob, he's now 50, and we've got some interesting people going on here. So we still haven't really done anything in terms of printing anything out to the screen. If I wanted to test my constructors, and this is not a bad, I'm going to go back to person. Not a bad idea to, there's tabs up here as well, but I keep closing because I want to make sure I'm saving it. It's just a habit I have. I just close the windows when I'm done editing it. I'm going to put something here that says, because we're going to test out the constructors, and I'm going to go put here system.out, if I spell it correctly. Print line in default. And capitalize the first character here. There we go. So this is in default, and then this one's going to be system.out.println in other constructor. I'm going to just have two constructors right now. Actually, I'm going to make a third one here. Let's make a third constructor. But let me add another piece of information so I can tell you how this works. So what else would a person have? How about a social security number? That sounds good. So integer SSN. So now I have integer SSN, so I'm here I'm going to say this.SSN is going to be equal to 555. So, and then in here, I'm going to leave this one alone. So if I just have a constructor here as an example, I was going to make another one, but I'm just going to modify this one now. Or, yeah, I'll just modify this one. This one only takes in N and A. What happens to SSN? Not going to be set. But I could just call the other constructor and to set SSN. Or, actually, let's just leave this one alone here. I'm going to do it this way. I'm going to modify this one here to put, because I'm going to create another one that's going to do something different here. I'm going to make this one integer SS. We'll just put it S for social security number. And we'll just do this here. SSN is equal to S. Let's make another constructor because, I don't know, we're in constructor mode here. Let's just make constructors. Copy. I'm going to make my life easier rather than having to type. I'm just going to copy and paste another constructor down here. So edit paste. So this one here is just going to set the social security number. Did you notice when I copied and pasted it, it gave me an error message before I removed the rest of those parameters? You have to make them all different. You can't have two that have the same parameter sets. As long as the parameters are different, the names can all be the same because they're all constructors. But you can't have two that takes on the exact number with the exact order. If I switched the order around, that would have gotten rid of the error message as well. So this one's just going to take on the social security number, which means I'm not going to have this one and this one. So this is going to be social number constructor. And let's just do one in that does the name and the string and the name then as well. Well, let's not set, actually let me go back here. Let's not set this one to do the social. Let me get rid of this real quick here. I'm going to take the social out of here. I'm going to bring this one back to what I had before. Because what I'm trying to do is call another constructor. So if I have this other constructor over here and the other constructor takes on A and N, but the person didn't have social security number and we just want to use the default social security number, we could set it with another constructor that just sets the defaults. So we can run another constructor from a constructor. It's called overloading the constructors. So if we had another constructor that took one in here, then we could run it. So as an example, if I did this, if I went on the top here, this dot and this, this, send it the social security number. Oops, wrong method. This one doesn't take on the social security number. Hold on, let me put the social security number back in here. Social security number's back. So put the social security number back. So you have the methods taking on the integer A, the string N, and the social security number. It's going to set the name to N, the age to A, but we're going to pass the S to this constructor over here. We can pass, if we already have one, I already have one here, I put one in here that said make the social security number equal to S. So I'm going to say this S to send this S, which means call this constructor's S. When we get to inheritance, we say super, which means send it back to the super's constructor that takes on just S. This one says send me to one of these other guys that just takes on S. So what you're looking at here is the concept of overloading constructors so that you're not reinventing the wheel. Yeah?
But in this situation, suppose you have another constructor created with the int parameter. It can be x and y. And if you call, how it will recognize which one to call?
The one that takes on one integer in this
suppose
particular
if you create
case.
another constructor with another integer parameter itself, which has just one parameter.
Oh, then you have a problem because then you have two constructors with the same footprint and the compiler won't allow that. You can only have, remember, you can only have one constructor with the same parameter set.
Oh, constructor itself will not be created.
This is calling a constructor. And so the constructors have this rule where all the parameters have, this parameter sets, the footprint of the constructor method has to be unique. So it's never going to get confused. It's going to know it's going to call this one. So now if I run this guy with the, I have to change my main now because I don't have one. I have to add it a social security number, and let's save this for now. Hopefully you don't have any error messages. And I'm going to go back over here, and now I see I have a message here. The message is going to say that I have the value of the local variable A is not used. Constructor doesn't exist. Yes, I know, I made it. It's undefined. So I have to put a social security number in here. I'm going to give this guy 999. So his social security number is 999. So if I run this, I'm going to get the methods, excuse me, the messages that print out here to give me the order in which this stuff is running. So we have the one that says the social number constructor. We have in another. So I'm going to just put here in 3 parameter constructor. And this is in default constructor. So I've got it a little bit, and I could probably put more comments on there if I wanted to. So now if I run it, I'm going to get this lovely stuff down here. Well, I got hello world still, but I have in default constructor, in social security or social number constructor, in 3 parameter constructor. So this happened first, if you haven't noticed that. So I put this, and this has to be the same as super, has to be the first line of the constructor, because the constructors fire in the reverse order. So when we see that, we're going to see this is we're going to build here. For those of you who came in late, we're repeating everything we've done, which is why this is at a fast pace. This is an entire repeat of last week, last time I saw you guys here, of 16 hours of lecture. So that's why it's going a little bit faster. So. The objects are built in the exact reverse order that they're made. So first we get object, then we get person, then we're going to get whatever we build on top of that. So we always want to put in the constructors, if we're going to call another constructor, we want to put that as the first line because that's going to be needed first. If we set the other stuff first and then we do this one last, we've messed up the order. It's not going to be sent back correctly. So always remember that if we're going to use super or this, it's always going to be the first line of the constructor. Before we continue, any questions on constructors?
This
Yeah.
is gonna be first line. I cannot put it anywhere in the constructor.
No, it has to be the first line of the code. Either you're going to put this or you're going to put super here. Only in inheritance would you use the word super. Right now we haven't done any inheritance yet. We only have one single class. You have to put it first because by default the object base is built first. Then the next object is built, then the next object is built, and so forth. So it needs it so it can construct the lower first before it gets to the higher. If you put it as the last item, it's not supposed to pick it up. Traditional older versions of Java never picked it up. I don't know. If you move it around now, it might work, but who knows. But traditionally, you put it as the first item in the method. Any other questions on constructors? The concept of the constructor is really important to know that, actually, because then we build on that, especially when we start looking at inheritance. So we also have this concept of setters and getters, and I know there's a tool for it. You can go to the menu and create your own setters and getters. Let's not do that. Let's just do it manually so we can see the concept here. The setters and the getters are generally in two sets for each one of them. I'm not going to make them all. I'm just going to make a couple of them because when we inherit, we're going to want to see that we can run these methods. Those are really the methods. They're public methods. These are constructors that we created. So let's create some public methods. Public methods have the same form, but we give it a name. So setters and getters will set the name, get the name. Set the age, get the age. So let's look at the name. So we know that a method has usually the word public in front of it, and they're called setters and getters because we can go this here. Get name. Well, get name is going to be void, so we're going to put the data type in front of it as well. And no parameters are going to be inside of the opening and closing brackets over here. This is empty because it's void. Well, not because it's void, but because void means it's not going to return anything. So this is going to be a problem because we're going to return something, we're going to get something. So we could make this one the set here. Let's change it to set. Set name makes more sense, but then we're going to have to put a parameter in here. What are we going to have to put in here? String. So string n. If we do that, then we're going to say this dot name is equal to n. Same thing we did in the constructor. So some people at this point would say, well, why do you want to do that? Because we have to set the name because we can't just say a.name is equal to something. We're going to use set name to set the name. So we use the methods to access the public methods to access the private data members. So we have to use these rules that are set inside of these methods. If we don't use these rules, then we violate the integrity of the class, and then the class fumbles down because we have so many things inherited on this, and we end up with problems. So that's a set name. So I'm going to copy and paste here because I don't want to type, and we'll go get name. Well, get name is going to return something. It's going to return an int, but it doesn't take on any parameters. So I'm going to take out the parameter list here. And it's going to be a different one. I'm sorry, get name is a string, you're right. I'm sorry, I was thinking age already. I was already moved ahead to the next one. String, thank you. String is going to return this dot name. All right, so string is we're returning, oh, there we go, indent it a little bit. We're returning this dot name. I'm going to use this all day today. We don't necessarily have to. We could just do this. Return name. I'm going to use this because then I'm going to really stress this and super today. So I'm just going to make a practice here. Just go this. Not a bad idea, only because it keeps track of which object you're in and what you're doing. So especially if we create another name, which we might do later on in this example. We don't know which object name are you talking about. So we can get different names to be printing out if we have to put different names on people. So, all right, so set name and get name, that's the setter and getter concept that we covered last time. Hopefully you're familiar with that. I'm not going to complete the rest of this class. I'm going to just use the name. But you can figure out, you probably want to do the same for age and social security number if you're going to build this program out. So, I'll be lazy and kind of leave it right now. Maybe I'll have to go back later, but we'll just see what happens here. So now out in main, we know how to run the methods, we would do this, and we would say, we have person that was created, and person that was created was using the default, so it's unknown. I'm going to get rid of this line now that we have the system line, hello world, because we have stuff printing out now, so I don't necessarily need hello world printing out anymore. So I'm going to set some information for P, which is going to be new person. So I'm going to go P dot set name, and I'm going to set the name here to Mary, because we're going to have Bob and Mary in this program here. And I'm going to get a little problem here. No, P's lower. Okay, good. So, and then if I want to, I can print out Mary's name. I can go system.out.println. Whoops. I spelled it correctly. Where's my... Oh, well. And I can go, P's name is... Or actually here, I can just put the call in here. I can put a string. P's name is something or other, or I could just print it out by just doing a get. So I can go P.getName. P.getName returns a string. So I can design it to concatenate it. I can design it just to print it out. You know, so now I can say if I run it now, I'm going to have Mary's name is going to be changed. P is going to be now Mary. So if I print it out to the screen, hello, I'll just use this one up here, run. I've got three parameters. I've got Mary now being printed out. So P's now Mary, so we can kind of see it printing out. So some people will actually do, you know, some simple stuff like this just to print it to the screen. That way you know it's working. That way you know, hey, it's working. Okay, good. Okay, so any questions on setters and getters as used in classes? No? Okay, good. So now we have the base person that we're working with. Let's make an employee. And the employee will be a person. And the employee will have an employee ID as well as a name, age, and a social security number. So I'm going to click on my package because I want it to show up in here. I'm going to go File, New, Class, like before. And in here I'm going to call this one Employee. And I'm going to leave this alone because I'm going to extend it on my own, and I don't think I have any inheritance objects in here super well. I could put this one in here in the superclass. The superclass of employee is going to be person. So I could rake this out and put in person, and I've automated the concept a little bit. Or I can add it later. So don't be afraid, oh, I left out the inheritance, oh no. We can always add it. We can always change the class. So now employee, the superclass to employee is person, so I'm going to press on finish. And now in here, this is the part I said we can add. So before, it would just be empty. So if we put it in here now, I have public class employee that extends person. So now all I can do here is essentially add stuff that's unique to a person. So what are we going to have in here? We're going to have, what did I say? Excuse me, employee. I'm going to have employee ID. What did I say I was going to have? String, no, integer, employee. Let's just right here put integer ID. That sounds pretty good. So now each employee has an ID. I guess that's what makes you an employee. Each employee, because we have extends person, also has a name and an age and everything else. So this is our inheritance. This is what we covered last time with Dino towards the end of that last weekend. And so now I can have some constructors. Usually I want some constructors inside of this class, so I'm going to put some constructors in here. What am I going to put in here? I'm going to put in here employee. Notice that the everything goes inside of the class implementation. I just a few minutes ago just made some space here to make sure I left this last closing bracket on the bottom. Everything goes inside, not like Objective-C. Everything goes inside. I had to remember that actually. I was thinking of Objective-C. I'm like, oh no, inside. Everything goes inside that class declaration. And there's no two files, there's only one file that goes along with this if you haven't didn't remember that part. So let's call this public. No, let's just call it employee. Employee, what are we going to have here? ID. selected your ID. Now I've made a constructor here, and then I can have another one here. I'll just go to employee. So let's make it the default. Not a bad idea to always have a default constructor. You want that is because ID is going to, if you start printing out ID, you're going to get garbage because ID is not set to anything. Do not come up here, I've seen this before, and do this. It works, it'll compile just fine. But when we start looking at inheritance, you're going to mess everything up. Plus, you're hard setting a piece of data. Why are you doing that? Have the constructor do the work for you. Because most people go, well, isn't it just easier and faster to do it that way? And then you're thinking about C at this point. You're not really, or you're thinking about, yeah, you're not even thinking about object orientation. You're thinking about procedural language. So here I'm going to go this.id is going to be equal to 0. So if they don't give me an ID, the ID is going to be 0. So now this is a better way of doing it than setting this value up here. But what if they give me an ID, then I'm going to go this.id is going to be equal to ID. And then I'm going to realize why I'm using this all over the place. If you go ID is going to be equal to ID, compiler is going to come back and say, huh? I don't get it. So you're going to get an error message. Or actually, hopefully, you're not going to get an error message and it'll work. But then further down the road, something really weird is going to happen. You're going to go, why in the world is it doing it this way? I don't know what's going on. So, but we have a problem when we make an employee. Or do we have a problem when we make an employee? We don't actually have a problem when we make an employee this way. Because name is going to be set to unknown. And in fact, let's go out here and make an instance. Right now we can make an instance of this. If we run this one here, and I'll put a C out here. I'll put a system out. I know I got 5 different languages going through my head right now. In employee constructor. Let's see, this is the employee default constructor. So if we make an employee right now, and we set the ID of the employee, and we get the name of the employee, it should come back to be unknown. It'll be set automatically by the default constructor. If we don't specify a constructor to run, at least one constructor will run from every object instantiation that we make. When we do an employee, we get a person automatically that's inside of the employee because we extended person. The person's default constructor is going to run, and the default constructor is going to set the name to unknown. When we print the name out to the screen, it should come out unknown. Notice in here, this is much smaller. We don't repeat anything for name and age, we just add the stuff for the ID. So let's see, let's go back to main. And let's make now, I'm going to put get rid of my spaces to condense this down a little bit. I'm going to leave this here. We're just going to add the functionality. Oops, as I get rid of the, so now down here I'm going to say employee E is equal to new employee. Oh, let's run the one with the constructor in it and set it to, we'll make the employee ID 20. That sounds pretty good. Now I can run e.getName. So actually I'm going to cheat sheet here. I'm going to copy this one, paste it underneath, and change this one to E.
So we are able to access class employee because it is in the same package?
Correct. It is in the same package. I covered that before you came in, actually. We're putting all of these classes in the same package. The default package, which is really unknown. We didn't actually specify the package when we created these classes. So we're not including or doing anything or importing because it's all in the same package. It says within the same scope. Makes your life a little bit easier. Eventually you're going to be creating packages and sticking certain things into certain packages, which is like a directory. It's just better organization, actually. And then you can include the entire package along with all of the classes in it, and then or import the package in with all the classes and stuff. And so when you create something you really like, you just reuse it over and over again instead of recreating it in each new project.
So what you're essentially saying is you can actually have the other classes used, which is actually defined in different package. You can have it imported there.
What do you think you do when you use anything that you import?
Yeah.
You're using something that somebody else created. Usually, most of it's made by Java, or the people that have developed Java, but you're using packages, you're importing packages. When you import a package, by the way, you're importing all of the classes that belong to that path in the package. So if you put this in a package, you can import this into another project that you're making. So we didn't actually specify a package here, which is why it says default package. Normally it would say a package name up here. There's a lot of chit-chat in the back of the room that's bothering me. Hello? Oh, see, I actually had to interrupt you so that you would hear me. Could you take it outside? Or keep it down a little bit, because I can't talk over that. Thank you. It's louder than you might think, actually, because of the room. It bounces. So. All right, so now if I run this project, I'm going to get unknown, and I do. So after Mary was the last line of code that we put in up here, then we added the new stuff here, and we added the employee E. So in the default constructor, which was, and I probably should have put person default constructor, but this is the person's default constructor that was created first. And then we have in employee default constructor, because we ran the default constructor. Well, it wasn't really. Yeah, did we run? No, I called it a default constructor, but it was really the one that set 20, wasn't it? And then unknown. So let me go back to this employee over here. It's not the default constructor. So in the employee ID constructor. So this is not the default. We don't actually have we have a default here. This is let's just do this correctly, because when we start making another class, then we can get this done here. So in employee, this is the default constructor. So now we can say, well, let's make another constructor, and let's set the name and the age in the ID, because this person is completely unknown. Because the default constructor of person in person default constructor person, and let's just do it this way here. There we go. Because I'm going to save this example and put it out on the website, so I'm creating my examples and lecturing to you at the same time simultaneously. So, but not a better way of going through it. So. A couple of birds with one stone here. Anyway, so we have the constructors labeled properly. Now let's make another one. So I'm going to do this because I'm kind of lazy. I'm just going to cut and paste it. In fact, there's nothing wrong with cutting and pasting it. But this is the error I was talking about. It's going to say duplicate method. Oh no, because I need to change the number of parameters that's in here. So I'm going to take on, let's say, what is the other one? Age. It doesn't have to be in the same order, by the way, as the previous constructor that I'm going to call. This basically is just going to be taking on an integer for the age and a string for the name and an integer for the ID. So this one, I'm going to change this one here. Employee 1, 2, 3. What else did we have? Social Security number. Let's do all of them. Let's do all of them here. I forgot about the Social Security number. Actually, we have the Social Security number set, though, don't we? If we had, just because of our design, and this is what you want to think about when you design your programs, due to our design, if I had just set and left the Social Security alone, I would have had it set anyway, because I ran this and sent the Social Security number to it. So you basically want to make sure all the data gets set to what it is you want it to set, whether you run it in the constructor you're calling or the constructor is going to call another constructor that's going to run it. So here I have integer A for the age, string N for the name, integer ID, and I can also put in here integer S for the Social Security number. Oops, if I spelled integer correctly, that's why I cut and paste, because I can't spell. So now we have one that takes on A. Actually, here, let's just do this, because it's too predictable here. Integer A. I switched the order. I think our constructor that we have in person, it takes on 3 items. Let's see what it does. Do we have one that takes on 3 items? Let's see. 3 items here. It goes A, N, and S. So like we did this to send the S over here, we're going to do that again, actually, because I'm going to send A, N, and S to this guy, to person. But he's now he's in the super class. So down here, I'm going to say super, and I'm going to go A, N, and S. Oops, I did that right. So super A, N, and S is going to call the super constructor that takes on age, name, and social security number. And then this .id is going to be equal to the ID. So when I run the employee, when I run this one, and this is the for employee for parameter constructor. Actually, it's kind of long. I'll just do here for param. There we go. For parameter constructor. Let's make an instance of a class. In fact, I'll just take the same one that we did here and run it. Now I have to remember. How does it work?
String then 3 integers.
String 3 integers. Okay, so the string, let's see. Let's go back to name. String, let's call this one Peter. I usually have Peter, Paul, and Mary in some of these. An integer, and an integer. He's 88 years old? No, that's the ID. That's the ID. I want to make him 88 years old. Let's see, wait a minute. Employee's got age, social security number, ID. Age, here he's pretty young. I'm going to make his age 80 years old. His social security number, this is the 3-digit number. And then his ID, he's 80. And let's make his ID, 67. I was going to go 666, but I'm not going to do that. So now when I get his name, because I really only have one method written, setters and getters, I'm going to still run a get name that was from person that I'm running on employee because we get everything we have earlier. So then I'm going to run this so you can see what it looks like. So I have Mary in person, social security number in person, 3-parameter constructor, an employee 4-parameter constructor, and then hey Peter. So Peter's now set and all his data is being sent back. And we haven't reinvented the wheel. We've used what we had. So we get from an employee all of the same functionality that we got from person. It's included in here. And now we can write stuff for employee. Well, what do we have for employee? We can set and get the ID. So it's not a bad idea to write the setters and getters. Let's set and get the ID because then we're going to make another guy that extends off of employee just so that we have 3 levels instead of just 2. And you'll see after the 3rd level it gets kind of boring. 4th, 5th, 6th. It's the same stuff over again. So now I'm going to say public get ID, and this is going to return an integer, and we're going to have it. What's wrong with get ID?
No, void.
Oh,
No. Return type is
oh, let's say it's a.
I had it down.
Oh, yeah, that's a silly message. I just started writing this one, so I haven't even finished it yet. It's all right. It's already giving me negative feedback. Return ID. All right, I hate it when Actually, now I'm in the practice of just putting in the opening because I know the closing is going to be created. And if they're going to, Objective C in Xcode, we'll put the return in there for you automatically too. So. All right, so and then I'm going to put in here a public. So this is good. Set ID void void set ID integer I. Let's just put an I in here. So now when I put this opening, it should put well public. If I spelled this correct, there we go. So then this is going to be this dot ID. Oops, this age. This dot ID is going to be equal to I. So I wrote setters and getters for the ID. That's the only setters and getters I'm going to write in here, because that's all I have in here is ID. Do not write setters and getters for name, age, and social security number. Those are already given for you. They're given for you in public. So now I can set and get the ID of the particular employee by running those methods. I don't think I have to run the methods unless somebody has a question about the setters and getters at this point. So now, just to make my life easier, I'm going to close some of these windows because I don't like accidentally clicking into the wrong one. Let's make another one. So employee, what kind of employees do we have? Teacher. Teacher's an employee. So let's go back and create another class. And the class we're going to create is going to be called a teacher. So file, new, class, teacher. And it's going to be an employee, so I'm going to go employee. So now I have a teacher employee. And then I'm not going to select anything else I don't need. I'm going to leave it on public. And we go finish. So now I have a third class. What does the teacher have? I don't know. What is the teacher going to have? He's going to give it something. Integer. Salary. Ah. Good idea. It's an integer value. Maybe I should make that a float. Double. Look at a double. Double salary. We can make it an integer. I don't know. Good idea. So let's see. We're making some constructors. So I'll just do this one more time, and then hopefully after we've done constructors 3 times in 3 different classes, you get the idea. We're just going to send it all the way back, but we'll send it back to super. And super is going to be the employee. Right. Yeah, so public, excuse me, not public. Let's just go in a teacher. Teacher, I'm sorry? Oh, yes, you're right. You're right. Let's fix that problem too. You're right. Objective C. Creeping back. Objective C is creeping back on me. Teacher. 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 Salary. This dot salary. It's going to be equal to. Is this the hourly salary or is this the national? I mean, is this the annual salary? Let's be conservative. $50,000.50. No, let's just go $50,000. 50,000? Or should we give him 40,000? No, seriously, teachers don't make that much. No, this is annual. I know it's monthly for you, but it's annual for me. So, no, we don't get paid that much. All right. We're doing this because we like it. Money? What's that? Okay. Yeah, that's why we do consulting work. That's where the money is. Anyway, so let's set the salary. Let's not just running politics today. I'm going to get fired. All right, so if we set the salary, we create a teacher. Oh, yes, I'm sorry. System out. I get too distracted with the salary. Inside in teacher default constructor. Alright, so now we're in the teacher default constructor. And now let's make another one here. Teacher to set the salary. Teacher, we'll put the salary first. Double salary. Well, here I'll put P for pay. Double pay, string name, integer age, integer social. Let's don't even bother. Let's just do it this way. String name. I'm just concerned with the name and the salary. Let's see what happens actually, because we're not setting any of the other stuff. Will the other stuff get sent? We might have a problem. Do we have a constructor that just takes on the name? No, because we didn't make them all. So here's the problem I'm going to run into. I'm going to have to go back and fix, because eventually I'm going to have to implement all of the different constructors, usually. So a lot of times you'll see a bunch of constructors, at least 4 of them, 5, depending on the number of variables that you have, data members that you have. Because eventually further down the road you're going to want to make a constructor and you're going to call back the super constructor, but it doesn't exist. So let's see what happens in this case. Because we don't have one that just takes on the name, do we? Actually, we might. That might be a bad example. See, that's an employee. Employee, we don't have a super that does that. We just call the default. That's going to send back. So employee. Well, let's just see what happens. Let's see what happens here. See if we can even get a message here. This dot salary is going to be equal to P. It's just super back N. And we're going to immediately get one that says the constructor employee string is undefined. We're going, oh man, can't do that one. We don't have one. So then I go, oh man, I have to go back here and have to make one here. So then we have to make it if we want to use it. So actually it's not too hard to do it. Just going to cut and paste this one here. So it's looking for employee N. Super is the inherited model. We actually have one that sets the name in person, but we don't have one that matches this. So string N from employee, we're actually calling employee string N. It's not person. We have one in person, but we have to think about everything in reverse order. Employee is going to call person. So it's going to trigger in the exact opposite. So this one here, what's it going to do? Well, we can't call super. This one doesn't exist. So we can say N. Well, alright, so I'm going to say this is the in-employee name constructor. It only takes on the name. Then, let's see, we'll change this one here, because what do we have? We're sending back to it just the name. So we could go super another one. So what do we need to set? Well, just set the name, and then we want the default stuff to go for everything else, right? So then we can go super, just run the default, right? And then name is in here. No, ID's in here. So we can set the ID to 0 if we wanted to. And name's going to be in the default. So name's going to be set to unknown. Unless we have something in to send back to name. Yeah. Oops, I'm on the wrong one. Which one did I just edit? Uh-oh, I'm on the wrong one. Here it is. Okay, so I edited the wrong one. This one is what did I edit?
Yeah, 0.
Yeah, this one's here going to be ID. Let's go back down here. This is the one I wanted. So I'm doing this on purpose to kind of show you what happens when you don't create all of the constructors with all of the different varieties that you might get. So now we have to think logically here and go, well, if I call super, I'm really sending the name. Name's coming in. I'm not doing anything with N. So what I really want to do is call super N, because I want to send the name back to super. So I'm working in reverse order to fill in information that I should have implemented to begin with that I didn't implement because I was lazy. So then I'm going to look at this message here and go, well, it's undefined. So I'm going to go back to person, and then I'm going to define what happens when I run the name. But here I want to make sure I also take care of employee information, which is just going to be ID. So I'm going to set the ID to 0. I could call this one up here and just run this, but it's just as easy and less confusing not to go, because you can run a constructor from a constructor. I can go this. You know, I can do this. Well, this. But actually not that context. I'm not going to do that. This ID is equal to 0. Probably a better way of doing it. Now I'm going to fix this error by going back and creating one that just takes on the name in person. So I'm going to go back to person, and now I need a constructor that just takes the name. So this one is very similar, but this one just takes the age. Looks like, you know, integer S, social security number. So now I'm going to create this one here that creates the name. And I'm going to put in here string N. And then what am I going to do here? Well, I'm going to take a look at these other ones here and go, well, this S, well, I can send it this S, so this S is going to be the string. So I can say, well, okay, so I could run, what was this one here? This one was this one. So I can run age. Do I have one that just takes on age and social security number? I have choices. I can just manually set it in here, or I could run the ones that are there. I can go this. So now I have the name. So I'm gonna fix this one first. I'm gonna go this name is equal to N. And you've noticed probably back over in employee, This goes away. It takes a few minutes, but it does go away. So now I'm back, and now I'm in person. I'm going to reinvent the wheel here. I'm going to go person in. Okay, so what else do I have in person to worry about? I have the age and the social security number. Do I have a method that says age and social security number? I could call that one. Or I could just reinvent the wheel, which, 9 times out of 10, you could cut and paste this here, stick it in there.
Or you can say this.
Or you can say this and send it back. Well, we don't have anything to send back, so we can just go this. So it's half a dozen and another which way you want to do it. I see it done both ways, actually. Hopefully I haven't lost anyone. You guys know what I'm talking about. We're trying to we've set one item in person, the name, but we haven't set the age and the social security number in this constructor. So just like this constructor here called another one, we could just say this, and it would set the name for us too, which is the issue actually. We're setting the name here. So what we could do, and this probably the clear solution here, is to go this dot age is equal to whatever our default age was. Oh, and I think we set it to 21. Huh? If you're going to do this, set it to the same value as your default constructor is doing up here. Social security number is 555. Half a dozen or another. You could call the other constructor. You can create another constructor and call that one from this one. You can just put it in here. So this one is now in person. This is the name constructor, yeah?
But in this case, since we are just passing
Mm-hmm.
we ideally should not set anything other than and.
Correct.
We should just call the default constructor in this
Correct.
case.
And then the default.
It actually leads to confusion otherwise.
You think this leads to confusion?
I mean, since you're just passing name,
Yeah.
when you're in subclass and you're inheriting this, and when you're calling this, you will assume that this is going to set the name, and rest of the things will be default, which is in the default constructor.
Yeah, you could leave. That's what I say. It's half a dozen or another. Some people think it's confusing. Other people think, I actually think kind of the opposite. I want to see it in here, because then when I look at it, I go, oh, that's what it's set to. I'm reinventing the wheel. I'm doing it twice. I don't really necessarily need to put this. What we're talking about right now is these two items here, whether they should be here or not, or should we just let the default constructor do it? I like to see it because then I know. For troubleshooting purposes, this is that might just be my own personal thing. Some people, like for example, he said, it kind of leads to confusion a little bit. But then I'm wondering, well, what was the age set to? It doesn't really matter. If I don't put it here, it'll put it somewhere else. I mean, I call another constructor.
So what I mean, when you're troubleshooting, you'll have to look at one place where this is going to be set up. When you're passing just the name and the rest of the other parameters, what the value is, you're setting it up just at one place. You're not setting it at different places. So he need not to look at the different places why this is coming.
Oh, but I'm the type of person that will go back and look. Yeah. So yeah, I don't assume, because you never know who wrote it.
Yeah.
Yeah, you don't know what's in there.
System allows it.
I'll look at the method and I'll say, what was in that method? What are they doing here? Then I have to think. Then I have if half of it's set and then half of it goes this, then I got to go another step. But I'm already at the base. Something if I'm at the base, I might as well just set this to that. So then you get some people that don't do this, and they have one for each one of them. Because this is up to you how you want to design this. Usually you're going to do one for each combination, eventually, if you're going to use it. Or you do what I did and go back and put in what you need, and when you need it. Otherwise, you get people that will have nothing, no constructors. Or you'll get people that put everything all in one constructor, and you can only call it one way. You can only make it one way. So it's definitely freedom of choice in terms of how you're going to design it. But what the goal is, and theoretically what you should be doing, is making the constructors work for you and not reinventing the wheel and not putting something in that doesn't need to be in there. As an example, commonly seen, really not such a good thing, is people try to set stuff. They'll try to make the data public so that they can set it. Like employees shouldn't be touching anything but the employee ID. Shouldn't be touching name or age or social security number. So, and teacher shouldn't be doing anything but the salary. So now we have it all working, and I'm going to close everything and make sure I didn't get any funny error messages or anything. So I'm going to go back to main, and let's make a teacher. So let's see if I can do it. I have to remember what constructors I have, so paste, and now I have teacher T going to be equal to new teacher, and the new teacher's name, do I have one that does this? We'll see what happens here. Teacher's name is going to be Barb, and we're going to go, and I'm going to look at this and go, oh, there's a fundamental problem here. I don't have a constructor that does that. So I go back to my teacher and I look at this and go, what constructor do I have in here? Just the double in the name. Bummer. Then I go, oh, you know what? Maybe I should make more constructors. I'm not going to do it. It's just too much busy work at this point, unless somebody really wants to see it. So, otherwise, I'm going to come back up here and I'm just going to run the one I have. It takes a double and a string. So here's my string and here's my double. 20,000. She just got demoted. And now we have this one, and e.name's not going to work here. I want to go t.name. What is this teacher's name? Should be Barb. Let's see what happens when we run it. Of course, I probably didn't change my comments. Did I put a comment in here? I didn't put a comment in here. Hold on a second. Let me just put this comment in here. Finish up my example so this is complete when I post it. Teacher, in teacher 2 param constructor. Let's run it, see how good we are. Let's see what happens. Run, run. Barb, she got set correctly. So now I have Peter in person name, in employee name, in teacher 2 parameter constructor, and then we have Barb that was set from get name. So we know that it's actually working. This is everything that we covered last time I saw you. And last time we did a dinosaur program. And the dinosaur program took on a dino. We actually built this in class last time if you weren't here. Made dino, and then we made different types of dinosaurs, and those dinosaurs had different things added to it. If you haven't done that assignment yet, not a bad idea to do that assignment. Because at this point, this is where we're going to start in with today's and this weekend's new material. So, questions before I continue forward with abstraction? No? Okay, good. So I'm going to trying hard to segment out these videos because people say they're too long. So this one was the review of everything we covered last time, all the way up through inheritance. So I'm going to stop this video.